Righty, hello. So I thought I'd give the advent of code a go. It's been out already 10 days, so we're a little behind, but it should be fun. I have already seen the first couple of puzzles and completed them, but then I thought I'd redo them on recording, see how that goes. So here we go. Let's get going. So Advent of Code, if you've never seen it before, it's got like one day for every day in the run-up to Christmas or the holidays. You see that you've got stars for which days you've completed, and every day you complete, you give it the answer to the puzzle that it wants, and it will give you access to the next day. So at the moment we're on day 10, but I've done the first couple. I haven't tried any of these ones yet. So here we go. We're gonna try and go through it step by step. See if we can speedrun the first couple, because as I say, I've already done them. I want to get to the ones that I've not actually seen before. But let's start with day one. So we've got some sort of story involving a chief historian who's missing, and we've been sent to solve puzzles. We're going to get 1 star for each puzzle that we solve, and each day is made up of 2 different puzzles. So the first puzzle, we're looking for, we've got a bunch of location IDs and we're trying to tally them up. So we've got some input, 2 lists side by side, bunch of integers, and we're trying to calculate what they call the distance. So they want us to take these 2 columns of data, sort them into ascending order, and then for each pair of numbers, they want us to calculate the difference between the numbers and then add up all those differences. So for this set of data, the distance is expected to be 6. So let's hop in. Let's get and do it. Well, first of all, let's copy this, and we're remembering the number 6 because we're going to use that as our sample. And we're going to do this all in Python. You are free to use whatever language you choose with the advent of code. It doesn't really matter what language you choose, but I quite like Python. It's quite good for this sort of thing. It's quite straightforward. You don't really need anything to do number crunching. You can just start typing and it'll do what you want. I'm on version 3.12. So let's just get into it. So we're given some sample data, and we're given an expected result, which was 6. Hopefully just said it. And we want to sort these 2 sets of data into columns of integers. So first of all, let's parse the data. So we take in a string, and what we want is a tuple of 2 integers, a list of those tuples. So we want a list of tuples of 2 integers as the result of this parse function. So take the data, split it into, can we split lines? Yeah, split lines, so we get a list of lines. Let's just remove this first new line so we don't get any empty lines. I guess we could also just, in the split lines, we could do a condition to make sure that the line isn't empty as well. We say if x. Let's just print this and make sure that that is the case. Parse the sample. We didn't like it. X for x in is what I needed to write. So here we go. We get a bunch of integers, and if we have new lines, we shouldn't expect to see them in our data. Cool. Okay, so now we need to, for each line, we want to also split that line into numbers, and then for each of those, we want to parse. In fact, let's just do a new function, parse line, and give it the line. Let's make another function, parse line, taking in the line as a string, and we want to produce the tuple. So first of all, we need to split the line by white space. By default, the split function can take a character, but by default it will split on white space. So parts will just be an array or a list of whatever is between white space. So we should get 3 and then 4 as a string, but we don't want strings, we want a tuple of integers. So return parts 0 and parts 1, but we want to convert it to an integer. All right, so we parse line and then print. Let's just return that as a result. So we should be printing out the parsed data. We see here, now we've got it in round brackets, which means it's a tuple and it's not surrounded by quotes. So we know it's not a string, it's an actual integer. So now we need to actually compute something on this data set. So we want to compute I think we called it a distance. So we take in what that function produced as data. And we're going to produce just an integer sum. So the sum is let's compute the distance on that. And the sum is, first of all, we need to separate it into 2 columns. So let's do that. Column 1 is the first element of the tuple, it's in data. And column 2 is the second element in the list of datas. Then the distance is, so we need to loop through this data. So let's just do it with indexes for index in, I'm going to use the range function, which will just emit 0, 1, 2, 3, etc. for whatever number you give it. So if we gave it like 3, then it would give us 0, 1, 2. But we actually want the length of one of these columns. Let's just, for safety, let's throw in an assert just to assert that the length of columns are the same, even though we kind of expect that to be the case. Let's just assert it so we're doubly sure. And let's get the 2 values from each column. Get the 2 values. And of course, we need to sort them into ascending order as well. So let's throw in a sort. And of course, because they're integers now, they should sort naturally. We don't need to give it any special function to do any custom sorting. They should just sort normally. Ascending integers. And now that's the distance. Let's calculate the distance is a minus b, and we want the absolute of that. And we want to add that to the total running sum. So sum equals sum plus distance. We'll return the sum. So now, for that sample data, we would expect it to produce 11. Is that the number we were expecting? Yes, 11. So now we want to do that with the actual sample data. Where's my sample data? Where's the actual data gone? Where is it gone? Can I not get my data now that I've done it already? Oh, get your passive input. Here we go. So here's the data we're actually wanting to work with rather than the sample data. That was just an example. So let's have a folder called data, and let's chuck the input in and call it input one.text for day one. So now we've got the data, we want to read in this data instead of sample and run it. Oh, sample result was actually 11. Okay, so right, let's read in that file. Read input, and this is also producing the same as. Right, it's just producing a string, isn't it? Read input. So with open input one.text in the data folder with the read flag, give it a variable name as f.read. We'll just read in the entire string and we want to return that. Let's just put that into a variable, result equals return results. So now, instead of doing that with the sample, let's do it with the read inputs. We see here, we get a giant number. Wouldn't even like to say what number that is at, 2 million, no? Big number anyway, and that should correlate with the answer that we got. So part 2 of this, same sample data, and now in order to find this missing fella, they want to also compute the similarity score. So for that, sort of similar deal, but instead of the distance, they want to go through each pair of numbers, and you want to go through each number on the left and count how many times it's in the column on the right and multiply the original number by the count in the second column. So it's sort of a similar algorithm. So instead of compute distance, we want compute, they call it similarity, the similarity score. So compute similarity score. So we take the same data set in. We don't really need to sort the columns now. We just need the columns on their own. And then for each column, so the sum starts at 0. And then for entry in column 1, sum equals sum plus similarity. And then that similarity we need to compute, which is entry multiplied by the count, like how many times it was in column 2, which handily is already a function in Python. Let's just grab that and then return the sum. So let's just do the same thing with similarity and see what we get. So here we get a different number, 237411109, and you'll see here that is what I also got here. So that's day 1 complete. Pretty straightforward. 58 lines of Python, so we're good. So on to day 2. So here you can see I've only done part 1 of this one. So day 2, we're in a nuclear fusion fission plant, and we've got some data which includes 5 digits. Well, actually, let's have a look at our actual data. Get your custom input. Right, so it's not just 5, it's just arbitrarily long list of numbers. And each row, each line constitutes a single report. So numbers separated by spaces. And we've got a bunch of reports, and we want to find out how many reports are considered safe. So we can only say that a report is safe, so a single line of input is safe, if it meets these criteria. So first we have to find out whether the level is increasing or decreasing, and whichever way it's going, it needs to be consistent. Everything either needs to be going all up or all down, and each pair of numbers needs to differ by at least 1 and at most 3. Okay, so that's fairly straightforward. So we've got a block of data. Let's make a new day 2. UI. Let's call that first one day 1. So day 2. So we've got our sample data. And expected results. Sample expected is we want the number 2. So again, we're going to kind of follow the same sort of pattern as this one. We want to parse the input. Let's import those type traits. So read in the input, and we want, in this case, we don't want a tuple of integers, we want a list of integers. So we want a list of integers, which means this parse line is doing just a list of integers. So rather than just 2 integers, we want a whole list of them. So in that case, let's just use a dictionary comprehension. So for x in line.split, and then convert that to an integer. And return that. That should give us a list of integers, and then for every line in the input, make a list of integers. So let's just print that out. Print parse sample, and make sure that looks good. Day 2. There we go. So list of integers, and now def is safe. So we want a function called isSafe, and it takes in a single line, and that line is a list of integers, and that's going to tell us as a bool whether it's safe. So let's assume it's not safe, and then work out whether it actually was safe. And we're counting counts. You need another function to compute the number of safe reports that takes in our parsed input and runs this function isSafe on each of the lines, and it returns the total count of reports that are safe. So num safe, start with 0, then for line in input, if isSafe line, if the report is safe, then increment our counter and return it. So in this case, we're expecting 2, so we better implement this function isSafe. So first of all, we need to work out, first of all, if the length of the line, if the number of elements in our line is less than or equal to 2, then we're always going to be safe. Actually, no, that's not true, because no, if the length is 1, then we must be safe, so we can just return true. If we're 2, then it doesn't matter if it's increasing or decreasing, but we still need to make sure we're within our thresholds. So let's define our safe threshold. Min was, let's double check what we're going for here, at least 1 and at most 3. So the thresholds are min and max, and this is inclusive. They're both inclusive. So for each pair of numbers, so first of all, let's put how many numbers we've got into an integer. So num inputs, let's call it readings actually. Number of readings is the length of the line. if the number of readings is less than 1 or less, is going to be safe. Otherwise, for each pair of numbers, so for index in range of num readings -1, then we want, so A is the line index into the array, and B is the next guy over. That's why we did the -1, so that our index wouldn't go out of bounds. So we've got the two values, and we want to say what's the distance. So that's the absolute. Let's just do B minus A. Then we want to know whether we're so first of all, what do we need to do here? I was going to say we could just take the absolute value, but we do care about the sign. So first of all, we want to know whether we're incrementing or decrementing. Is increasing. We're going to set that to none to start with. Then if increasing is none, we want to calculate it off the first set of results. We could probably do this outside the loop. It would probably be a bit more efficient rather than in here. Yeah, let's just do it outside the loop. Don't need to do that every single thing. We're going to do it right off the first set. So if the second element is greater than the first element, then we're increasing. Otherwise, we're either the same or decreasing. What do we do if it's the same value? It's not really defined, is it? The value is the same. Oh, here we go. Unsafe because it's neither an increase or a decrease. Oh yeah, because it's under our minimum threshold. So it doesn't really matter because it will fail anyway. So calculate whether we should be increasing or decreasing. And then here we want to say is pair increasing, and we want to do A is greater than, no, B is greater than A, and we want to know that that matches what we calculated from the first instance. So if these are different, then it must not be safe. So here we're kind of assuming that it is starting off as safe, and then we're saying this becomes not safe. And here we can just break out because we don't need to keep calculating every other element. It's not safe, we need to jump out. So if it does match, then we need to say whether the difference is within our thresholds. So if is increasing and distance is either less than the min threshold, as in 0, or come on. Why can we not do brackets in Python? Oh, no, we can. So that, or distance is greater than the max threshold, then the report is not safe. But then we need to do the negative case. So else if not increasing and distance is, so here we need to invert things. So if it's less than -3 or greater than -1, then we're also not safe. And again, we can just break out at this point. And that should be it for our function here. It's safe. So let's do the sample. What do we get? Nothing, because we didn't return anything. We need to do the count safe. There we go. 0, so that didn't work. Okay, so Python debug time. Can we debug it? So none of our reports came out as safe. Weird. So our input is that first line. Looks good. Are we increasing? So 7 to 6. No, we should be decreasing, so that should be false. Num readings is 5, so again 0 to 4. Oh, -1, +1. 2. Okay, there we go. So now we're good. 2 is the answer. So for that sample, but we actually want our input data again. So let's grab that function to read in our input from here. At this point, I probably would start to refactor because I hate copying and pasting code. So I'm not even going to run it. I'm already going to have a util function because I don't want to copy and paste this lump of code, even though it's a few lines. I just don't like copying and pasting. Let's have a utility function. And because it's in a folder and we need to import it as a module, we need to add a init.py, just a blank file, just to signal that it's a valid module. Let's put our read input in here, and let's give it the day as an integer. So let's do some magic in here. So we need to format our integer. Let's give that a go. Is it 2 zeros? The good thing about Python is you can always just write Python and you'll get the REFL, which is like a prompt where you can just type any old stuff in there and it will compute it. So let's just see what happens if I assign day a number and then print that, get day 7, so that didn't work. So how do we pad this with zeros? Can we do pad? At this point, Copilot would probably kick in and help me, but let's just Python string format integer reading zeros. There we go. That's probably about right. zfill. Oh, okay. zfill. Okay. So we need to convert it to a string and then use zfill. Yeah, looks about right. Cool. Okay. So we need a read input function. We don't need this guy anymore. We just do input equals utils.read input, and we're on day 2. And now we need to import that. Let's just print. Oops. No, it didn't work. Data. Oh, we haven't actually created the file. Okay. Let's do that now. So we need our inputs, which is here. One, that doesn't seem right. input is 1. Is that right? No. Oh, because that's the first character of the input. So we need to parse it first. If we parse it, and we get a list of posits, then it should get the first row. There we go, 14, 17, 20. Okay, we're good. So now I want to go back to day 1 and also use that. Return utils.read. Day 1. Let's just double check that day 1 still works. Yep, we're good. Okay, so back to day 2. Where were we? So we need to count the safe things for the real inputs. What do we get? It's day 1 and day 2. 202. Is that right? Personal answer was 202. There we go. So we got 1 star for that. And now we're on to the bit that I haven't done. So here we go. The engineers are surprised by the low number of safe reports until they realise they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what otherwise would be a safe report. So same rules, except that if removing a safe level from an unsafe report would make it safe, the report instead counts as safe. So we need to repeat what we did, but if it turns out it's unsafe, we need to rerun with each of the elements removed to try out what it would be like. Does that make sense? So we need to count safe is safe. So is safe now needs to, if it wasn't safe, here we go. So if the report wasn't safe, then we need to copy the line with 1 element removed. So num entries. We should make this as a separate function, huh? Count safe with tolerances. And let's do it with our sample data first. We pass the sample, and we're expecting, once we've implemented this, we're expecting the answer to be 4 once we implement this tolerance thing. So if it's not safe, then we need to copy the line. So we can use line with a colon with no numbers. So copy the entire array. And then we want to do we want to go through each element in this array for I in range len line. And we just want to remove that element. We pop support index I. So we just kick out that element, and then if that is now safe, line copy, then we want to do num safe. So it's either safe right off the bat, or else go through each index. If any one of them is safe, increment our index and then break. Continue on to the next line. So now, do we get 4? Get 4. So now, to answer the puzzle, do that on the actual data. We get 271. 271 reports are safe, which is right. Cool. So now we can finally move on to day 3. After I have a drink. Okay, day 3, mull it over. Computers are having issues. Any chance you can see why our computers are having issues? So we've got some corrupt input. The goal of the program is to multiply some numbers. It does that with instructions like mul x, y, where x and y is a number. And it's expecting to multiply those two numbers together. However, because it's corrupted, it can't run. Oh, even with spaces, it's corrupt. Okay. So here we go again. We've got some sample data. So let's do another day3.py. Oops. And our sample is here. And our expected result is 161. Okay, so we kind of want to follow a sort of a similar pattern here. So we want, and in this case, we don't really care about lines. We're actually doing a regex. So we're trying to find, so let's do a regex. Trying to find mul with brackets. Do we need to escape these brackets? Probably. And then a set of digits, and then a comma, and then another set of digits. Let's use a plus because it's 1 or more. It's between 1 and 3, but let's just do plus. We need to extract these numbers, so we need to put those in brackets as well. Let's extract this as well. We don't really need to. So we've got mul, and then we're finding a set of numbers, then a comma, then another set of numbers, and we put those in brackets so that our regex is going to group them. So let's just print. Let's first re.compile our pattern. Let's just put it in here. So what do we get if we regex that? Find all on sample. Oh, that doesn't look right. What? What the hell? Why is that giving that? Day 3. It's a bit weird. Let's do the old debugger, Python debugger. It's not the input I was expecting. Oh wait, 2455, it's giving us the groups, it's giving us the numbers. I don't know why I thought that was giving us day 2 input, but no, that is actually giving us what we want. So we do x for x in find all we've got the tuples of the groups that matched. So that's cool. That is kind of what we want, I suppose. So matches equals regex find, and then for sum equals 0, and for group in matches. So that's, it looks like it gave us a tuple. So let's see if it actually did give us a tuple. But we need to convert it to an int because that's not an int, that's a string. So A and B, and then sum equals sum plus A mul B. And the sum. We get 161, and that was expected. Okay, cool. So now let's run that with our proper input. Let's grab our proper input, and we've got, oh my Jesus, God. Ooh, that's a whole bunch of random gibberish. Let's use our util function for this. So utils dot read input. The day is number 3, and our input is here. Oh, let's make this into a function. Def num matches. No, what are we doing? Sum. No, this is some sort of computer input, right? Sum of the input, taking a string, we return a sum. We return an int, sorry. Right, what do we get? 161. Okay, so we didn't actually. What? Oh, sample. So we actually want this to be the input. We get a giant number. Let's give it a go. That's the right answer. Okay, cool. Part 2. As you scan through the corrupted memory, you notice some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get even more accurate result. Okay, so as well as parsing mul with brackets, we also want to parse do and don't, and that sets a state that changes whether we're going to actually process the mul or not. We need a most recent apply, so it's sort of a stateful thing. We start enabled. So with our sample input, let's this in here, and we sample 2, expected result 2, and that expected result is 48. So it's saying because of this don't, it's going to ignore these muls in the middle until we hit this do. Whew, okay. So we need another sum function, sum with conditionals. So we kind of want to do the same as what we did before. Let's leave that for a minute and do it with the sample. So we're expecting 48 when we include this. So our regex, we need we need to not just be doing muls, we need to do, there's 2 ways we could do this. We could either do an OR with the whole expression, or we could capture this mul here as a variable and see if it's either a mul or a do or a don't. I guess let's capture this first thing. So it's either that or a don't or a do. Do we need to escape this or no? So here I need to get the REPL open and actually try this because I don't know whether we need to escape this pipe, the OR pipe. Let's do regex 2.match on the sample. No. So maybe we want to leave these pipes in like that. Do we need to put that in brackets as well? No, because that would... Wait. So if we do mul, comma, no, pipe, do, match that against the string mul. Do get a match. So we don't really want to do a find all here. We want to do a match on what? For m in text inputs. Oh, need to do the second mul. So we also we don't want this comma for the do's and don'ts. So that's not really going to work either, is it? So I guess, can we move all this brackets into the mul and then put the bare brackets here? Is that how we've got to do it? Is that going to work? So either the expression we had before, or don't with blank brackets, or do with don't with blank brackets. Is that going to actually give us any matches? Let's find out. So is multiply enabled? So we start with it being enabled. Don't really know what we get out of this mul. I guess let's debug it and find out, because I'm not really sure what this is going to actually give us. So we are going to compile it and just run it and see. So sum with conditionals on the sample. Let's see what we get. Unexpected indent. What? So what is M at this point? Oh, it is a match. Okay, that's cool. So we do get a match. And then what do we have for groups here? We still do get our 2 and 4, that's cool. But what about when we get a do or a don't? So here we go, we got a don't, and then what do we get for groups then? None and none, interesting. So we either get a tuple of our 2 integers or a tuple of nones on the case of a do or a don't. But if we do get a do or a don't, then our match dot match is going to be dot match is going to be, no, it doesn't work. So you can also run the function dir on an object just to see what functions it supports. So M supports all of these functions. Oops, where's it gone? Group, groups, last group, pos. So match isn't a thing. So how do we get out the actual do or don't of this thing without matching it? We could just match it as well. That might be easier. So if we match this expression, is that going to do any damage? If we match that, that, and that, and then rerun it, then we would expect a tuple of three elements. So it's either going to be mul, string representation or number, string representation or number, or don't, then null, null, or none, none. Oh, actually get quite a few nones. That's not really what we want. So now we just get a tuple of 5 things, which isn't exactly ideal. I guess we can work with that. Just a bit ugly that we have to compare. I guess it works. So if the tuple group's 4th value has don't, then we know it's don't. If the last one has do, then we know what to do. Okay, that's fine. We can work with that. So m.groups, and we want mul a b don't do. So we unpack the tuple. So if don't, so if don't, then is multiply enabled equals false. Else if do, then we toggle it back on. Else if mul, then we do our sum. Okay, let's see what we get. What do we get here? Day 3. Oh, we need to convert these to integers because they're strings, of course. And 161 was the expected of the first one. Oh wait, we need to actually not do the, if that and this is true, then we do the sum. Now it's 48, which is what we want. Okay, cool. So now, rather than doing it with the sample, let's do it with the actual input. And we get a giant number. Is that giant number the actual answer though? That's right, 1 gold star. Whew, okay, we're on a roll. Number 4. Series search. Looks like the chief's not here, so we're still trying to find this guy and he's not here. So now we fix the computers. Time for the next bit. Pulls out a device and pushes the only button on it. After a brief flash, you recognise the interior of the monitoring station. So we're doing a word search and we're finding one word, which is Xmas. The word search allows horizontal, vertical, diagonal, backwards, or even overlapping words. It's a little unusual because you only need to find Xmas. So we've got a bunch of characters and we're trying to find Xmas in this big block of numbers or letters. So in this sample data, we're trying to find 18 Xmas's. Okay, let's do it. So we're on day 4 now. Day 4. So how are we going to approach this then? Don't know why they're showing the input again with dots removed. I feel like that's not super necessary. Okay, so we're trying to find Xmas. It's not really a regex sort of a thing. I mean, it could be. There's two different approaches really. We could either transform this data into lists of long strings of text and then just use regex to find the word Xmas. But we could also just do the sort of brute force approach, which is for every position in the two-dimensional array, look for Xmas forwards, down, left, up, and the diagonals. So 1, 2, 3, 4, 5, 6, 7 searches, or 8 searches for every single position. Which is better? I dare say the brute force approach is more intuitive because that's kind of how you would approach it as a human. We just go from letter to letter and see, can you see the word Xmas? So I guess let's do that. So we've got our sample data and we want to go through, first of all, we want to convert it to a list of let's say stirrer, but it's actually a character. I don't know, does Python have the concept of a character? I'm not sure. Let's have chur. So let's do that instead. A list of churs. So data.splitlines and export x in that. And parseLine, same as before. And line dots. Export x in line. That should return us character, yep. I'm out of beer, it's devastating. Let's just print out, what's that giving us? Yeah, okay, so we've got our data. Now, I guess we want some search patterns here. We want to search from where we are, 0, 0. We want to go, if these were x and y coordinates, we want to go forwards 1, forwards 2, forwards 3, and we want to compare to Xmas. Let's just do this as a so that's what we're trying to find. And these are the grid coordinates that we're searching. 0, 0, 0, 1, 0, 2, 0, 3, 0. And then we also want to do the same backwards. So we might just do an exhaustive list of coordinates here, might just be easier that way. This is where having Copilot installed would really be quick because it wouldn't mess around. But let's do backwards. And then let's do vertical. So here we want to swap these around. So let's go upwards. And then let's do down. And then we need to do the diagonals. Here's where it gets a bit more interesting. So the diagonals are 0, 0, 1, 1, 2, 2, 3, 3. And then the negative of that, so that's from here upwards in a diagonal line. And then the final two search coordinates. So we want to go right and up, right and up, right and up, and then left and up, like this. So I think that's every combination there is. So left to right, right to left, bottom to top, top to bottom, diagonally down and to the right, diagonally up and to the left. That's to the right and up, and to the left and down. I think that's all the combinations. So there we go. So we've got some search patterns now. For each character, we need to do these searches. So it sounds like it could be a bit brute forcey, and it very much is brute forcey. So let's take our data. And we're producing a count of how many we found. What's wrong with you? You're missing a bracket somewhere. So we need to do for x equals 0, no, for x in range. So we're kind of assuming, we need the width, which is, let's just take the first line and do the len of that to get the width. And then to get the height, it's just the number of lines. Then for x, let's do for y in range height, and for x in range width. Then we can get our starting coordinates is x comma y. Now for search in search coordinates or search patterns, so the coordinate we actually want to search is the starting coordinate x plus search x. And then coordinate y, start coordinates 1, search 1. Now we need to ensure it's in bounds. So if coordinates is greater than or equal to 0 and coordinate x is less than width, and same for y, coordinate y is in bounds. He's not happy. So if the coordinate is in bounds, then we're good. Else we don't really need to continue with this search for that particular pattern, so we can just continue. No, that's not right. So one of our search, no, these need to be lists, don't they? Needs to be a list of tuples, not a tuple of tuples. Not that it really matters, but the search patterns is a list of tuples. So for each entry in that, we get a list of tuples. And then for item in search, for delta, let's call it delta in search, delta should then be a tuple. Delta x delta y equals delta. Let's do it like this. So if something isn't in range, then we don't just continue. We actually just want to say that this whole pattern is a fail. So let's break out. So we want to start assume that we have found it until we haven't found it. And outside of this loop, if we still have got found, then we must have actually found it. So sum equals sum plus 1. So then coordinate. So if the coordinate is in bounds, then we need to also compare whether the character matches. So for that, we need to index into this list. So we kind of need to enumerate this list as well to get the index. Search index. The search index should be a number 0 to 4. And then we need to, the character we need to find, desired character, is our compare here, the search index. So that will give us the character that we want. So X on the first hit, then M, then A, and then S. And the actual character that we got is data, and then the coordinate Y, and the coordinate X. So again, if desired character is not equal to actual character, then found equals false, and break. Okay, I think that's it. So if we run this, what do we get? None. Oh, we need to return 18. And what were we looking for? 18. Okay, so now we can get our puzzle inputs. and run it on the actual input. Oh, oof. Oh my goodness, that's a lot of Christmas. Okay, so do it again, but instead of that, we need to import our util. Grab our input. Day 4, run it on that. 2,414, what do we reckon? That's right, 1 gold star, woohoo, part 2. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle, it's an X-mus puzzle in which you're supposed to find, oh my goodness, in which you're supposed to find 2 MAS in the shape of an X. This isn't actually an Xmas puzzle, it's an X-mas puzzle. So we're looking for MAS. Irrelevant characters have been replaced with dot in the above diagram. Mass can be written forwards or backwards. Okay, so we've got slightly different kind of word search now. So let's do some more sample data. Sample 2 equals that data. And we're expecting 9. So, how are we going to do that then? So it's kind of similar but different. So we always want the A in the middle, and then we either want M or S. Wait. So Xmas can be written, or MAS can be written in either way. Each mass can be written forwards or backwards. So it can be MAS or SAM or MAS, SAM in either combination. So we need a completely different search pattern here. Let's call it mass search patterns. So let's assume that 0, 0 is the A. Is that intuitive? How are we going to do this? We could say that the A is in the middle, and then we're looking for does this really can we reuse this code at all? I'm not sure that we can. We're kind of looking for 3 letters this time, a grid of 3 by 3. So instead of 4 letters, we only want 3 letters. So we want -1, 0, 0, 1, 1 for one row, but also the other row and we're looking for MAS. Because we're trying to find MAS. So 2 lots of MASs, and the search pattern is for the first MAS -1, 0, 1, and then the corresponding X 1. So that sorts the first one out. So I think we need 4 permutations here, because we need this way and this way, but then backwards and this way, and then backwards and this way. So bottom right, top left, and then top left to bottom right. Yeah, it's 4 combinations. So that's the first combination. Then the second combination is we need to reverse this in one axis. It's kind of hard to think about in one's head. It'd be easy to write down, I think. Yeah, we want to reverse this section, then we want to reverse this section. So I think we just need to swap these 2 around to reverse it. And then the next combination, we want to use this one and reverse these 2 elements. And then lastly, we want to reverse both elements. So this one with this one, and also this one with this one. I think this is, if I get this right tonight, this will be my lot for the time being, I think. Okay, and we're still searching for double mass, so let's do mass compare. Right, and then let's do search mass with the second sample data. Oh wait, can we actually just, let's just put this as a parameter, the patterns and the compare, rather than having it as globals. Then I think the same algorithm basically works for both, except that we need different variables there. So there we go. So we don't really need a separate implementation in this case. So let's run it. What do we get? Because you get a nice fat 0, so that's no good. Why not? Oh wait, we need to actually update this. Nine. What did we want? 9. Okay, here goes. Let's just run it on the main data then. 1871. That's right. 1 gold star. All right, so we did 4 days. We're doing well. We've still got another 6 days to catch up. And I think we'll leave that for another day because this is already getting quite long. But there we go. I hope that was informative or interesting. That's advent of code from a game developer of 20 odd years. So my Python's a little rusty, but I do use it on occasion in the business. It's nice to get some do some exercises in it just to play around with the syntax, and it's also nice to see what other people are doing and see if their sort of solutions match mine. So a lot of people have very strong opinions about Python and how Pythonic things are, but when you're doing exercises like this, it's don't know how interesting it is to sort of be super strict with the language. In any case, that's all for today. That's good enough for now, and I'll see you again. Have a good night.